In step 4, we will add our new design into the model and evaluate their performances. The first example is about evaluating different program allocation. We first embed the same OSM map data as in step 1, then additionally embed the capacity information using this amenity capacity component. It automatically synthesizes the capacity according to the amenity types. Next, we will begin to model our new design scenarios. In this example, we will first model 3 buildings each with their height information. We will also model the amenity points and assign their activities. Finally, by combining the old buildings with the new buildings, we can then construct a final model, based on which we can conduct the simulation. This time, we will need to select by destination factor mode and choose the destination factor as amenity capacity. By looking at the simulation results using the building hits and street hits, we can compare the results before and after so that we can start to have a sense about how the design will change the foot traffic in the built environment. We can also do some comparative study between different scenarios. We modeled here another 3 buildings with exactly the same density and amenity types. Combining all these new buildings into the model, we can then do another round of simulation, and then looking at the street hits and amenity hits again. We can observe the difference in terms of the performance. In this case, this location is a better choice than this one to place the supermarket store and the department store because it receives a higher amount of foot traffic. We can also test with different types of amenities. For example, in this case, changing the supermarket and department stores into restaurants and fast food will increase the building hits and street hits. Another useful metric here is the amenity score, which describes the relationship between the amenity hits versus the capacity. It can indicate whether a business could be financially sustainable. This is a list of every single amenity on the map and its corresponding amenity score computed based on the simulation trips. In example 2, we will evaluate some changes on street network. This is the existing streets from the OSM. We bake them to the Rhino and then add 1 new street here. We select them back to the Grasshopper and use them to construct a new network. When we plug in the new network into the model, we can see that both building hits and street hits increases in this area, while this building hits decreases, which means adding this new streets is more beneficial to this development rather than this one. Example 3 is about evaluating building level walk score. This can help us identify which places are more walkable than the others. We use the same model and buildings as in the last example and plug them into the walk score trip engine component. It computes a walk score for each input building. With some simple visualization in Grasshopper, we can see that the walk score is generally higher in this scenario rather than this one. This location with the highest walk score can be a most valuable location in this project. We can potentially put a highest density here because a higher walk score usually indicates a higher property value.